Hello everyone, today I'm going to show you the use of HEC-SSP here. This is a statistical analysis software. It's not only for hydraulic analysis, but it could be used for other statistical analysis, and I found it's quite useful in my research. I download this one from the website. I download this portable package, so you don't need to install it. Just download and use it. The examples included in the package are very good to learn from. But today I'm going to show you how to do a study from scratch. Let's call it video 1 here. Video 1 is this. So there are 3 parts included here: analysis, data, and the map. Let's start from the data. You just need to import the data into the software. There are several ways to do so. You can either do it from the USGS website, the Excel, the manually, or the text file. So when you have the data from other agencies like NOAA, I suggest you do this way. The Excel is very convenient. But today I'm going to show you the USGS website, which is more convenient. There's several types of data here: daily, annual peak data, and the real time, and the instant. And you have flow and stage data here. So I'm going to show you download some data in Florida. I'm living in Florida, by the way. Let's look at data in here. Data Beach. Import. Done. You can have the 2 data here. First one, you look at the data here. So every year they have a maximum. They have a peak flow. The flow has the unit of CFS here. This is for 24 years, and this is for say 13 years approximately. You can have a look at the values, the actual values here. It's not the in this way. I think they use the water. This is not the calendar year. It's the water year, which I will show you how to do it later. Let's look at more data here. What about daily data? In Florida, again in Daytona Beach, Florida. The 4 stations here. Import. Done. So as you can see here, these 2 are the same. Basically, this one shows the continuous data, and this one shows the maximum each year, and this one corresponds to this one. And you have the stations here. So how can you view where the station is? The ways to do it is to import the map here. You can use the map from the example site here. For example, the maps. Open. Here it's close to Daytona Beach, which is here. And then we want to download another data. And you want to look at the 50 minutes data. Excuse me. Let's see, Daytona Beach, Florida. It's nothing. So a way to do it is you look at the website. The USGS have a website. You have to look at the map. They have all the stations there. All the working stations there, I guess. So around Daytona Beach, you can find 3 stations. Let's try this one. Let's copy the stat number, clear the table, get working. Oh, we had the set here. Import. It shows that I have to give a date. I cannot show. What about last year? What year? Let's see. Till the end of. Should take some time. So let's look at data here. So from June last year to this year, July, you can look at the values, the actual values in the tablet. Okay, let's do the analysis. Then there are several analyses you can do. I'm quite familiar with them other than this one, constant frequency analysis, because I never used this before in my own research. The others I use them more or less, but this one I never used them before, so I won't show it here. So to do the analysis, you have to do the bullet 17. Basically, this shows the calculated return period versus the flow of the water level. Name practice 1 flow data. We can use this one 13 years. Show the years here. There are 24 years. Probably can use the station here. Have more data. Options. Use the values from the table below. So this is the output of the frequencies. Stay here. You can look at the data here. Calc compute. Oh, done. So you can plot the curve here because we don't have a lot of data. So if it's 10 years, the values should be more accurate than the 100 years, because for the 100-year return period, you do a lot of extrapolations. Those extrapolations can cause a lot of uncertainties, as indicated here. So you can read it here. It's about 100, 2, 3, 4, 5, 440. And you can read the actual value here is 443. So this is this one. And we can use the 17B method here. We don't change anything here. Use the default option. The advantage is that you can use the historical data. For example, you have a long period, but you have another historical is 1920. You have a peak of say 500, and you can apply the data here and compute it again. Look at the data here. So you add this one here, totally change the curve. For the 100-year data here, we have 100, 200, 300, 280, 290. Look at data here is 284. So it totally changed, only with one value. It shows that the uncertainty is real. When you have 20 years data to calculate a 100-year return period, there are a lot of uncertainties involved. So you should be really careful using those data. And you also have the confidence interval here, the 5% and 95%. So you know your uncertainty here. This is the bullet 17 analysis. Let's look at another one, the general frequency analysis. Start practice 2. Let's first look like the analytical scale. And this log transform means you want to use the log scale of the data or not. For do not use log scale, you have more functions to fit in the distributions. If you use the log scale, there are less functions. I'll show you why. This is so-called the water year, start from the October 1st. That's the reason why you see two data in the same calendar year, but they are in a different water year. Let's use the default function here, analytical, use the value here. So here, when we use the log function, we have 4 to calculate. This is the error of momentum, this is EMA. When we choose do not use log transform, you have a log generous extreme value analysis. And probably can use the calculate the layout. Try to calculate complete. Got it. You can see here there are some outliers here, and they have the curve here. For different curve, you can choose different distributions. What about the log scale? You use the EMA. There are a few data you can choose from. There are separate settings you can choose from. Let's look at it. It's very similar to the first analysis, the bullet 17 that we have done before. You have some outliers here. Basically, you fit the curve well. Other than that, we can use the empirical simulation. Do not use it. Use it. Years. It shows at least 3 points that you require, which means you have to define 3 points here. Compute. I think I have it. Right. You have this curve, and you want to calculate the curve by itself. So you want to fit the curve this way, and you should make sure that it's not descending. So the value should be descending here. Calculate, not descending. So we have some descending. Basically, here you define the values, the values, and then they calculate the uncertainty for you. I'm not sure when should you use this function, because I don't know really. I never used them before, but I show you this is the way to do this analysis in SSP. So you basically define your own function, and they calculate the uncertainty for you, other than trying to fit distributions. And you may have the question that which one should I use, this distribution log normal or the other functions? I'll show you later in the later analysis. The third one I want to show you is the volume frequency analysis. Let's call it practice 3. Let's use, I'm not sure which data to use right now. So what's the use for this data? This data shows, this is too short. Probably I need to use a longer one. Oh, yeah. Probably should use a longer one here in 24 years. It separates data into 1 day maximum, 3 day maximum, 5 day, or 10 day maximum. And then you will know your values, like duration in day, the 1 day, 3 day, 5 day, 7 day, 10 day, 15 days. You can delete it all here. For example, we just want to 3 of them. Use the table below. I don't want to use this result here. Duration table. And let's go just use the EMA here. Compute. Compute complete. So basically here you have the 1 day, 3 day, and 5 day. You can zoom in here to have a look at data. So it's 1 day is higher than 3 day, higher than 5 day, which is expected. Sometimes you can see 1 day is 3 days higher than 1 day, but this is not very common. So in most occasions, you can see 1 day higher than 3 days, higher than 5 days. So they analyze the 3 day maximum, take the average of them, and then they fit the curves. Now we need to plot the analytical curves here. We need to zoom in here. Yeah, look at here. So 1 day on top of 3 days, on top of 5 days. So in this way, you can calculate the 3 day maximum, 5 day maximum, or 1 day maximum, which is useful for some. When I was doing some like global climate model analysis, I was working with the 5 day, like say the 5 day rainfall, the 10 day rainfall, or the 5 day extreme hot weather, hot temperatures, to show the extreme weather change, extreme climate change. So this is a 3 day, 5 day analysis. Before doing that, let's close this one. Before doing that, I want to do another bullet 17 analysis. Let's see. The second one. Let's use it because we need to use it later. I prepare for this one. Yeah. Use another bullet 17 analysis. Practice for this one. 17. Use default settings here. Default settings here. View. Plot. See another plot here. So with 10 days, with less data, you have less. You have higher uncertainties with a 100-year estimate. Now I think it's okay to proceed to the next duration analysis. Duration analysis means how much, so how long the flooding will be there. So we call it duration analysis. Practice 5. Let's use probably this one. Use all the default settings. You can choose here whether annual. Let's first choose the annual here. Evenly spaced. You can space your beam. Now I just do the evenly spaced because the first time you do it, you have no idea how large it is. So the time exceeding the 300 is very small. The time exceeding say 150 is about how much? Let me look at there. 150 is about 1%. So 1% of time, the flow will exceeding 150 CFS cubic feet per second. And what about here? We want to do quarterly. We plot data here, compute, and we plot the curve. So this one should, so the annual one should be in the middle of the 4 curves here, as you can see here, which is expected because this one is the combinations of these 4 curves. If you zoom in here, you can actually find 4 curves here. This is On top of this, so we can see the quarter 4 in the winter there's like high probability to have large flow, followed by the quarter 3, followed by quarter 1. And summer is the least one. So this is done. It's quite easy. 5. I won't go this one because I'm not familiar with this one. Let's go to the curve practice 6. Number of curves. So curve combination analysis, what it is? It means that you have like the frequency analysis like from here. Let me show you. If you have the frequency analysis from here, so you have this probability and this corresponding flow, and you want to have another, you have like another probability analysis from other agencies or other data, and you want to manually input here. So the way we just input a few probabilities here. So for example, 0.01. So you have this 1,000. So this is just my guess. Not 0.2 but 0.3. Can 700 is now. It just guides the data. You don't want to make the data perfect because so what about 300? 1.3. About 500. 10 from here. 250. Apply data here and plot. It says at least 3 points are required to define graphic. So you have to ask the same way. We have to fit the curve ourselves. Which means something is not descending. We have to make it descending. Let's just ignore it here right now. Like compute. Something's not descending. It should be descending. Let's see, 100, 90, 80. Oh, it's really weird. It's kind of weird. What is that? Oh, the label. Yes, the label. Let's call it label. The unit. Let's call it Navic 58. Users sometimes just need to look at their error message. Let's see. Yes. So I have a curve that combines the problems from both of the studies. So you can just, if you want to include more data here, if you want to insert 2 rows here, 0.01, 0.1, and you have to redefine the curve here. So look at it here. So the 0.01 is 897. So basically, when you have the data you have from multiple sources, and you want to combine all the data together, you should use this way. But like again, to be honest, in practice, never used it before, because it's kind of weird for me to drag this point and show the data here. It's just me. Maybe you can just use use the data to fit in the new distributions, but it's not how it's done here. I'll just show you how to use the software here. What about the balanced hydrograph analysis? Practice 7. Let's use this again. We don't need to change the label here. Here. Let's use how long? Let me see. Probably 20 days. Won't be too long. September 12, 24, and end date 21 September 2012, 2022. Excuse me. Use the analysis import here. So this is the no, not this one. It should be. I should import it here as well. Because this one, the practice 3, has the 3-day analysis. Yeah, you can see this decreasing here. This is 1 day, 3 day, and 5 day analysis. This is 15 minutes of analysis, assumed to be 15 minutes, because I didn't do it this way. Let's apply and compute canal distribution support distribution table. Oh, that's why. Oh, let's cancel that. Let's see this 1 day daily analysis. Volume frequency analysis. Just change the curve here. So this is the first time I have this question. So let me have a look at it. Yeah, like I know the problem here. We only have 1 day, 3 day, and 5 days. When we do the we went to the duration analysis. We have 1 day, 3 days, 5 days. Oh, I want to put it here. So this is my output frequency, which means will be shown on the plot. We have the frequencies like here, the 1 day, practice 3, 3 day and 5 days from practice 3. See, this one are the one that we generated before in this practice 3. I want to plot the frequency here. You can see the 1 day, 3 day, and 5 day. I can plot this is the one showing that what if here, they have a peak here. This is the 10%, 5%, 1%, 0.5%, and 0.2 percentage of how the flooding will look like if we have like this. If you have longer data, then you should have more. Let's try here. Let's see. let me try it here. I'm not sure it works or not. Yeah, it works. You have a longer period, how it involves um, versus the probability. So this is, I'm not quite familiar with it here because I know how to use it, but in my real project or in my real practice research, I never used this before. So you can resort to the example set for more data or for more practice. And this one, I use it a lot, distribution fitting analysis, which means practice. Here. So we have a flow data here. This is the annual data, flow annual peaks. Let's use it before. Let's use it first. Excuse me. And then we will show you how the other data works. We want to do some analysis here. They give you the best fit. This is the best fit. Based on the score here, the smaller the better. So this means the generalized logistic function give the best fit of the CDF and the PDF, and followed by the normal for the Pearson. You can check the data. They have the PP plot, QQ plot. QQ plot is pretty useful when you determine which function is better. You can see the CDF plot. So we don't have a lot of data here. I'll probably just use the one, the first one that's recommended here. Looks pretty decent. What you can do more is you can just filter data. The way to do it is just use the, not annual peak, but like for example, the flow here. We want to filter it out. Filter it out. Filter by season, no. Filter the maximum start. This is the calendar year. Apply. Then this is the data we have. The CDF, PDF, the XY, which is very. You look at each year, they have the maximum. They should have the maximum each year. They have two maximums. They should. This is the year. When you do the calendar year, when you do the water year, you have two peaks here. But when you do calendar year, you only have one peak here. Let's fit the data analysis. The best one is normal distribution. Looks fine to me. Looks fine to me. So you can look at the data. They have two tests, different tests. Both show that normal distribution is the best one to fit the data we have here. They have a data analysis. This is pretty useful when I was doing the data analysis, the fit the best curve of my storm data, like the storm parameters. I need to fit the best data. I did it in MATLAB. MATLAB has some libraries to do it, but you can also do it here. They have a lot of functions. Not only show here, they have a lot of distributions here. You can see it. So they are good enough for you to do the analysis. Let me see what else. Filter it here. You can just filter by the time window, like you just use it from 90 12, filter by season from March to October. Apply, okay. And then you find the distribution analysis from JEV. Yeah, this is the data. So you can do a lot of data analysis here, the extreme value analysis. Yes. So let's work on the last one. Mixed population. Oh, this is also very useful. This basically combines two PDF or CDF into one. Say if you have the PDF of the river discharge in summer and the PDF of river discharge in winter, and you will calculate the PDF of the whole year. You cannot just simply add them together because that's not the way that perfectly works. The way it works is to the Euro ways to do the Monte Carlo simulation, and you can basically consider all the possible outcomes and sort them together and do another PDF. And here they do it for you. Practice 1, practice 10. So we have two number of curves. Imagine that flow, flow is existing analysis import here is existing for import here. We have two analyses. We want to compute, say, so this is the first one. So maybe this is your summer distribution and this is winter distribution. You want to combine these two CDF, two problems, two CDF into one to calculate your CDF in a year. And the way to do it is to do some statistical analysis. Here we can combine here pretty quickly. You can calculate the, probably you want to do it longer. So the way to do it, just need to let me check. Okay, probability and yeah, this is the way you combine them two together. You cannot add them together because that's not the way it works. All right, thank you. Hope we can learn something here and see you next time.